So thanks very much for coming. I hope you enjoyed lunch. Hope you've enjoyed the content so far. Of course, as ever, thanks very much to all the sponsors. Make this event happen, but especially all of you who've bothered to show up. I was really excited to come here. It was nice to start off with a little story. So yesterday evening, I was flying out from New York. So in the check-in line, online check-in didn't work, and then I was in a long line and got lots of frustrating error messages and saying, oh, you have to see a gate agent. Nobody told me what was wrong. Then I discovered at the gate that, oh, you need a visa since November 2017 to come to Canada. So, great, that's fun. I'm going to fill out a 4,000-page form in like 10 minutes. And I'm telling this story because amazingly enough, within 10 minutes, I got a confirmation email to say, yes, yeah, my requests have been approved. So if all software delivery were that quick, wouldn't that be a lovely place to be? I was expecting that I'd spend 6 months and have 500 ServiceNow approval tickets somewhere before it would be ready. Anyway, I got very lucky. The Canadian government has built a decent system that actually sort of seems to work. And I managed to make my flight and my connection. And now I'm here to talk about open hybrid continuous delivery stuff. I think, so who am I? I'm a member of the Spinnaker community. My day job, I work at Google. I've been in the sort of deployment, continuous delivery, container, release, DevOps, cloud, add lots more buzzwords. We can put AI and ML in there. And then we have all of them in blockchain. I've been in this space for a long time. I've been at various points of this diagram, if you like. I've been a product owner, I've been a team lead, I've been a developer, I've been the head of duct tape, and now I'm back in a role which is kind of like chief PowerPoint officer, which basically means I get to go and talk and share some thoughts and advice and things. I've slaved through organizing events like this, so I have a lot of appreciation for the people who made this happen. I think the TLDR is basically, hopefully, I've experienced enough pain from enough angles to at least have a hopefully interesting opinion. So, what to talk about today? We have about 40 minutes, not a hugely long session. I want to spend a decent amount of it going through a bit of a demo. But I want to start out by, trying to prepare this talk, I was really thinking about, what do I like when I'm going to a talk? And of course, it's so fun to see nice screens and visualizations and, oh, look, I committed a line of source code, and now it's in production. Like, we've only seen this demo 10,000 times. So that's not really that interesting. I like to come away from a talk with a slightly different perspective on a particular problem space and something I feel I can apply to my day job when I go back next week, or Monday, Tuesday, whatever. And so I'd like to do that here by trying to break down a little bit of the discussion around deployment and continuous delivery and really look at it from a little bit of a different perspective and try to see different types of value in this particular process. And then I think hopefully give a little bit of a framework for how you can go away and figure out which types of value are relevant in your context. Because there's definitely not a one-size-fits-all space. And understanding where your complexity fits and what your needs are is, I think, very helpful because it's an incredibly complicated and diverse tooling ecosystem and best practice ecosystem. And picking out the bits that work for you hopefully can be much better than like reading 10 million blog posts and Stack Overflow answers and trying to piece together something that works. I'll obviously talk a little bit about Spinnaker specifically and how Spinnaker tries to embody some of these things. And we'll look at some of the specifics of that, and then depending on the Wi-Fi gods, we'll either fall back onto some slides or some videos, or we'll actually go and click around and wait for screens to load. And then if we have some time left over, we'll do a bit of a Q&A. But the takeaway slide, if you want to go and check your emails from this point on, this is really the three main takeaways that I'm trying to get across here. First of all, beyond a certain level of deployment complexity, and we'll talk a little bit about what that means, I think it makes sense to consider a dedicated deployment automation tool. And I hasten to add that doesn't mean you should get rid of whatever Swiss Army knife tool you already have. Everyone has a Swiss Army knife tool. It's totally necessary. But this is a dedicated additional tool for deployment automation. What does a deployment automation tool do? Second main takeaway. It supports best practices both for rollouts, application rollouts, and what I call application management, which is a vague term that I'll get into in a little bit more detail. And obviously, the third thing I would like you to take away is that Spinnaker tries to embody a bunch of these practices, plus layer on a bunch of nice domain-specific secret sauce that Netflix and lots of others, but Netflix originally have discovered over many hard years of trial and error and pain and late nights and whatever, and hopefully that's something that people can take away and not have to do themselves. All right, let me just look. Sorry, I have plenty of time. So let me get started on the first part of this, where we try to break down continuous delivery, continuous deployment. We're not going to get into that debate, application deployment, into some concrete areas of value. And how would I like to motivate this? Well, I'd like to motivate it by what I consider to be a bit of an anti-pattern. Just as cloud and DevOps as terms became whatever you wanted them to mean. So I think continuous delivery and continuous deployment and CI and then this awful CI/CD combination have devolved into just a phrase that means glue or balls of mud or both, right? It's just random scripting of random sorts. So if you like to think about it, like really the space is really so thought of in some kind of weird way like a combination of this, right? Or all kinds of weird hybrids. Unfortunately, if you type Google image search ball of mud glue, like you don't get anything interesting or useful, so I didn't have anything to show you. But I don't think this is very useful because really this is totally talking about implementation details of what's going on here. Must get this script to run after this script, or then this container task with these environment variables with this set of repositories, blah, 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 blah. And yes, we can deep dive on that all we like, but that really doesn't give you a good sense of what you're actually trying to get out of it. And also, if you look at it purely from that perspective, like which tool is the best tool to spray out my glue or assemble my ball of mud, then it's also very difficult to make tooling choices. And so instead, I'd like to look at this from a different perspective. And I'd like to start by motivating this perspective from the observation that application deployment sits at that really interesting boundary between build and run or build and manage or whatever you like to call these two phrases. And I'm not going to rehash the entire story of DevOps and how this is the organizational silo boundary, blah, 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 blah. I think it's more interesting to perceive of it as a state change, right? It's a state change in the life of an application. Up until that state change, you're doing stuff with an app, a release candidate typically, or commit or whatever, and lots of processes happening, and you're validating it and doing good stuff. And then with application deployment, it goes from the process of deployment, if you like, into a state where you now have a running thing living in an environment with a particular version, with particular attributes, health, status, whatever. And it's recognizing these two sides of the coin of deployment, if you like, that I think help us understand different areas of value. And so, in a short phrase, let me try to motivate them as three different areas of value. So there's application rollout. That's the process part. That's making sure you can run all the steps that you need to get an application running. And then there's application management, which is, okay, now I have a given version of an application running in a given environment. Now I need to do things with that. We'll talk about that a little bit in detail. But from the very basic question of I need to understand what's running where. And anybody who's tried to do that with, especially VM-based setup, it's really hard. Like I have 50,000 auto-scaling groups or managed instance groups, and I've got a bunch of load balancers, and then they've got all these other infrastructural components, and so you've got this entire soup of Lego bricks, and you're trying to figure out how that relates to this logical concept that you call an application. Even if you take a really nice modern runtime, like Kubernetes or something, even there it's really hard. And the community is recognizing this and doing work around it, or OpenStack for that matter, no difference. And then there's domain smarts. So yes, these first two are interesting, but of course, there's some really specific things about the domain of application deployment that you can really add business process value, such as execution windows. We only want this process to run between 2 and 5 on a Sunday, or something like that. And how to enforce that, and how to do that in such a way that you don't end up with horrific amounts of glue scripting. There's clearly some value in there. So what's application rollout? Well, that's the part of CD that I think normally comes to mind when we talk about it. And as I've said a few times, I think that only thinking about it like this is a bit of a failure mode. This is the process of taking a release candidate through a number of verification stages to production. I think another slight failure mode is when we think of CD as this wonderful, magical notion of, oh, I've just committed a line of source code, and then do 1,000,000 steps, and da-da, production. That's great for like git push Heroku. Like this is a demo that we've seen since 1990, whatever. The reality is that in large organizations, I mean, that's not to say that this doesn't happen. For a huge percentage of your applications or WordPress sites or whatever, this is totally legitimate. But in any kind of non-trivial setup, there's very often a distinction between what I call decoupled CI/CD. There's a distinction between the developer feedback cycle, which is I've committed a line of source code, and now I want to tell the developers useful stuff about that code, and the build a release candidate and take that release candidate to production cycle. So that's what I would call decoupled CI/CD. And the reality is that for any non-trivial application, this is by far the most common practice. Like, I don't know who, mobile apps, back-end applications, anything that's shrink-wrapped software doesn't get delivered on every commit. That's just nonsense. And so, first of all, just having this as a framework is useful. That doesn't mean to say that combined CI/CD is a bad thing, but it does mean that we shouldn't necessarily think of deployment as being triggered by a commit. We should think of deployment as being triggered by the existence of one or more release candidates. And if you go into some of the more advanced things like release trains, where you're actually triggering more like on a daily basis, then this whole trigger per commit notion really falls apart. So how do we do application rollout typically? Well, it's a sequence of commands that we need to run. So very often this is done with a general purpose orchestrator, GPO as I'll call it, or an automation tool. And this could be Rundeck, or it could be Jenkins, or it could be Concourse or Drone, or 10 million others. The range of processes that you need to execute varies hugely, and this is, we're sort of looking ahead a little bit to the complexity thing. It can be as much as git push, or as little as git push Heroku, which is a simple app, not many environments, and the runtime takes over a large amount of the quote-unquote complexity. But it can also be a long-running multi-step process. Let's sacrifice New Zealand, release a new version over there, wait 2 days, then add another continent, et cetera, where a rollout process can be, oh, well, I'm supposed to take a break. It's always, I thought I'd switch this off, but clearly that didn't work. Anyway, well, I'm sorry, I can't take a break right now, my bad. This will come back in 20 minutes, so I have to be fast. So long-running multi-step processes, that's the other end of the spectrum. And the more complex this sequence is, the more you run into challenges that are kind of specific to this domain. Git push Heroku is not a complicated automation sequence. Like, you got to get the credentials right and whatnot, but that's really about it. But when you start to have these long-running things, you start to get into things like access control. Some of the steps are non-automated. You need to understand exactly where you currently are. So being able to say, well, which percentage of traffic is going to which region right now, which of the processes are actually up and running and healthy and so on, that becomes really important. And if something goes wrong at any particular point and you decide, well, this is really a bad idea, we now want to recover to some previous state, understanding and having the ability to undo those changes in a granular way is really important. Maybe another way of looking at this bullet point specifically is that at the simple end of the spectrum, deployment can really be a black box thing. Git push Heroku, just go do it. Doesn't matter if it breaks, I'll just do another one. At the more complex end of the spectrum, it's really not a black box. Like, you really want to be able to see what's going on in that box. Because just trusting that it's going to do the right thing over a period of 48 hours or whatever, and it's just impossible. So yes, there is some essential complexity if you look across different teams, but there's often incidental divergence. What I mean by that is if you take an organization and you look across 5 or 10 teams at how they're doing their deployments, a lot of cases you'll find differences, and some of those differences are necessary, but often the differences are just because there's no good way of sharing best practice. People copy-pasted Jenkins files or whatever, and home-cooked their own solutions, and they diverge a little bit and then a little bit more, and then suddenly you're at this position where you take a developer, you come onto a new team, you have no idea how their CI process or deployment process works. And you have to relearn it from scratch, and you're back in that frustrating cycle. First time it's your job to be the deployment manager or whatever. It's like a super painful experience. And I think we can get rid of some of this. Application management. So this is more often considered like an operational thing. Oh, what's wrong with the application? But really, and those organizations that are trying to do DevOps, obviously, they try to make this more of a developer concern as well. I think the fundamental question here is, which versions of which applications are running where, and what's their state? clearly, general purpose orchestrators do a really, really bad job of this because they don't have any notion of this domain model. They don't know about applications. They certainly don't know about environments. The best you can just about do is encode things into names of jobs. Like, this is the job that deploys food to environment bar. And then I can look at the job execution history and try to reverse engineer what's running where. Bamboo did a kind of decent job of this, where they at least provided some screens to embody that convention. But by and large, this is really a terrible experience. So what always happens is you have 3 tabs open at the same time: the process runner tab, some infra overview tab, and maybe your monitoring tool. Or guess what? Companies build their own dashboard, another failure mode. Monitoring tools, of course, they have the overview, but they have very little notion of what changed. And often they also look at things from a very infrastructural perspective. So that you see a whole bunch of VMs, for instance, and a bunch of running processes, but you have no idea what applications those actually represent. And if you're doing containers or things like that, that becomes even worse. This becomes a significantly harder problem, of course, if you have multiple types of runtimes. So if you've got OpenStack and some Amazon and some Kubernetes and some Heroku and some whatever, then you're going from 3 tabs in your browser to 8 tabs in your browser if you're trying to get some kind of consistent overview. And they all have slightly different models of what an application means, et cetera, et cetera. So this is a really hard problem. But it's not just about understanding your application landscape. It's also about, oh my God, we're really low on capacity. We need to scale this thing up right now. Or help, this application looks like it's on fire. Oh, I can see it was redeployed 5 minutes ago. Let's roll back to the previous version. Let's move some traffic over to the hot standby that we still have. All these kind of emergency remediation actions that you need to carry out. And you want to do these safely, right? There's a lot of talk about managing your applications as code, and so you have an enormous pile of YAML if you're doing Kubernetes, or a pile of Terraform, or a pile of whatever to run this. And I can guarantee from personal experience, when you're just trying to make that emergency production rollback fix, that's when the typo happens and you start taking out an entire region, and even Amazon isn't able to prevent this internally. So clearly, almost none of us are going to be able to do this internally. Ergo, in a high-pressure situation, you really, really don't want to be manipulating code. You really, really want to have a nice, safe, big button that says, are you really sure? This is what you're going to do. Are you sure? And you want to have approvals, and I'll show you some examples of that. So, and then there's domain smarts, right? So this is clearly another area where general-purpose orchestrators by design and by definition can't really help. One example is, so you say you're going to say an autoscaling group. I'm going to deploy new applications as an autoscaling group. What does that mean? Well, it doesn't mean I'm going to make an API call, and then I'm going to wait for Neutron or whatever to come back and say I'm done, because actually what it means, that means I'm starting. And now a whole process is happening where the VMs are starting and traffic is being sent to them and so on and so forth. So yes, from an infrastructural perspective, I've created an autoscaling group. But from an application level perspective, that's not interesting. What's interesting is that the application is running and serving traffic. Kubernetes, new version of that, same problem. Like, you give it this deployment object and say, here, go do this thing. And it says, thank you, I'm going to do that eventually. And that's fine from an infrastructure perspective. But from a deployment perspective, it's really not good enough. Because you really need to know that those processes, again, are running and serving traffic and so on. Other things like being able to grab artifacts from a context. So you get a trigger, like a code commit or an artifact push or something. And now you want to use these artifacts as first-class objects in your pipeline, another domain-specific problem. And then a whole bunch of this kind of application manipulation, such as rolling back to the previous version, directing traffic back and forth, and so on. And there's a whole bunch more. I'm looking at the time. I'm going to speed up here a little bit. Ways of sharing best practice, doing things like traffic guards, making sure you don't accidentally remove the last instance of an application that's serving traffic, having a consistent domain model, canary analysis, et cetera, et cetera, et cetera. So, all right, talked a little bit about the 3 areas, I think, into which deployment breaks down. And now, let's answer maybe a secondary question, not what to look for in a deployment tool. That was the first question. This is when to look for a deployment tool. We all start with a general-purpose orchestrator. Everybody has a Swiss Army knife, and that's totally legitimate. I think it's wrong to think of deployment as a one-size-fits-all problem. There are tons of applications out there for which the Swiss Army knife is the perfect tool, and you do not need another one. We should be happy recognizing that adding any other tool to your tool stack is a huge amount of cognitive overhead and, of course, also operational overhead and so on and so forth. So this is a natural choice to start with, and it may be also a natural choice to end with. But at some point, having this general orchestrator becomes really painful, right? It stops being a general purpose orchestrator and starts becoming like a Rube Goldberg device. This is a copy of our first CI server that we had, part of it. Anyway, even at this point, once you realize it's becoming painful, teams naturally shy away from looking at something else because, again, of the overhead. And this is the classic space where everybody says, yes, we know it's a problem. It's something we want to do better next time. And guess what? It never gets done. And that's natural, and that's normal, right? And there's a natural reluctance to accept the need for a new tool. But there is also a necessity at some point to say, OK, when is enough enough? Like, at some point, enough is enough. And I think deployment complexity is a useful way of thinking about this. So the formula for no, I'm just joking. Like, there's no formula. This is not rigorous science. This is just a sort of a rough guide to evaluating your scenario. And so there's a number of dimensions here. They differ for everyone. This is more like one of those personality tests you get in one of these magazines. Like, if you've checked 7 out of 12 or whatever, then you're type X. How many teams are doing deployments in your scenario? How many runtime platforms do you have to manage? How many processes, how many deployment processes are you running? That starts to become a problem if you have scalability issues, for instance. You don't want to be wasting half your time keeping your orchestrator running. How complex are your rollouts? Are they more at the Git push Heroku end of the spectrum? Or are they more of the spectrum where you're having to pull together many components and run many stage rollouts with some sort of business process steps in between, such as approvals or reviews? Do you have to enforce strict separation of concerns, an access control model that clearly specifies who can do which thing at which point in this process? Do you have to meet regulatory audit, concerns, compliance, all that kind of stuff? There's obviously more, and I'm not claiming this is the canonical definitive list. But these are good things to think about. And so how do you use this kind of stuff? Well, OK, so I would suggest, here's my handout sheet, if you like. Go ask yourself these questions. If you don't recognize any pain, then I think you're in a good spot. If you recognize pain in 2 or 3 of these dimensions or more, then I think you're in a good position to start looking at a dedicated deployment tool alongside the general purpose orchestrator you have. And then commit to a time box with a real project that has this pain, and make your own evaluation criteria that is actually dedicated to these pain points. So a big failure mode I've seen, and I used to sell enterprise commercial tooling in the space, that people would say, oh, I can't be bothered to figure out what we actually want the tool to do. We're just going to get the Gartner spreadsheet. That's totally useless because all you're doing is going through some enormous feature-by-feature checklist, 50% of which are really of no relevance to you whatsoever. So don't do checkbox exercises. Don't go through pre-provided spreadsheets. And don't go through endless bake-offs. Take a project, take the time, build your own evaluation criteria. Try it out. This is not a free lunch. So it'll take some effort. And if you decide to adopt a tool, there'll have to be people dedicated to watching it. And you'll have to train some users in this and so on. But in some sense, it is a bit of a free lunch. Because, well, maybe it's not a free lunch. You get a bunch of free snacks, if you like. Typically, you'll find that these tools, especially ones that are still under active development, have a bunch of interesting features that shouldn't sway your decision about whether to adopt it initially or not. But you will get much more value out of it over time. Because there's really cool and interesting stuff in there that you will find useful, even if you didn't really feel that you needed them initially. And another interesting thing for those of you who work for sort of larger enterprise-y corporations have hiring challenges, it's quite surprising how, and so obviously I'm thinking about Spinnaker here specifically, but there's a bunch of funky open source tools in this area. Being able to say, we're using this open source tool, and maybe we get a chance to contribute back to it, and then being able to say to your platform engineers, hey, you get a chance to work with Google engineers and Netflix engineers and other companies, that's a pretty cool thing too. And that actually has an enormous draw, much more than one might imagine. All right, so 15 minutes. So now let's talk a little bit about Spinnaker. So what is Spinnaker? So it's an open source project. It was Netflix's original app rollouts platform. It's the V2 really of their platform. Their initial one was Asgard, and then they rewrote that as Spinnaker. And it's led, if you like, the main development is done right now by Netflix and Google. And there's a bunch of other companies contributing, and there's some things in the works there as well. It aims to embody the deployment and operational good practice, plus to incorporate some of the kind of domain-specific secret sauce, and to do that across multiple runtime platforms. So it's not just made for AWS, say, or for GCE, or for OpenStack, or for Cloud Foundry, but for all of them. And it tries to have a model that makes this possible, which is, I think, well, sometimes it can be a bit of friction, but it's also an enormous element of value. And so, well, Netflix built it because they found that, in short, and I'm not quoting them on this because I don't know whether they used Jenkins previously. I know they still use it. Like, most tools in this space fall over after a certain scale because they're not built to scale to like thousands of processes a day. And then you end up in this horrible hell where you have like a multi-master setup with weird proxies in front of it, and you do all kinds of crazy sharding, and then just life is just a misery. And so Netflix said, no, we have to build this properly. And then, it also provides that application-specific abstraction layer, which I think speaks a bit to its kind of application focus. Boris was talking about that earlier from Mirantis in slightly different terms. So they have one Spinnaker instance, just some numbers. Netflix, it does a lot of stuff. Like, it does like thousands and thousands of deployments, runs lots of executions, and that kind of, it just works well, right? And that means that, yes, it's not a jar file. Right? It's a complicated application. It's a microservice application. This is some architecture diagram. It's much less interesting. I will prove to you that this is a real architecture by showing you the real architecture diagram, which looks more like this. And that proves that it's real. No, it's a complicated system, right? That's just a lesson. For those of you who are trying to sell or who are being, even worse, told from a top-down perspective, time to go to microservices, you go from one jar file to something like this. To scale, manage, operate, debug, trace, aggregate logging, like it's a non-trivial problem. Again, no free lunch, right? But the reason I'm showing this is to show you the fact that the lesson building a system like this for this kind of scale is that you have to build lots of individual components that do different things, that do like communication with infrastructure, that do UI rendering, that do orchestration, et cetera, et cetera. Trying to pack this into one single Java server is just not going to work, as we know. Right. So Spinnaker scales far beyond most other tools in this space. And again, I want to be careful here. That's a nice attribute and really cool numbers, but it may not be what your pain point is. So don't pick it just because it's a scalable tool if you don't need that scale. But be aware that it does really scale. It's non-trivial to configure and operate. Obviously, work is going into making that better, but don't kid yourself here. It is non-trivial. It has a provider model, a sort of driver abstraction, if you like. It's called providers to support different types of underlying infrastructure. And it has an abstraction model, like a domain model, to go with that, which can sometimes mean that if you're using it with a single dedicated provider, like you're only doing, say, serverless, or you're only doing OpenStack, or whatever, then the vocabulary is not the vocabulary that you might be used to from that provider, which is a bit of a point of friction. There's some work in progress trying to make that a little bit better. And then, of course, there's lots of integration possibilities with other tools. So orchestrators like CI tools upstream, and registries and monitoring tools and code registries, repositories, and all that kind of stuff, so that that management experience, that point of glass, is pretty good. All right, demo time. What are we going to do in the demo? So even though I sort of smirked at the beginning about the git push Heroku demo, I'm going to do a slight variant of that because we just have to have one. But I'm not going to show you that in huge detail because, frankly, it's not very interesting. You see lots of flashing lights, and at the end, something is deployed, and yay, But we've been able to do this for 15 years. So there's really no value in that. I'm going to talk a little bit about the rollout process, application management, and then some domain smarts. And I'm going to jump back and forth just in the interest of time between the UI and some screenshots as a result. All right, enough slides. Let's go. Right, so Spinnaker. Let me just make the screen size a little big here. So applications, application-specific domain model. There's an RBAC model here that controls which bits you can see and which bits you can't, which applications you can control, and the underlying accounts that are used to actually communicate with the target system, because, of course, this is not done using your credentials. This is done using the credentials of they're configured for the automation. So the pipelines view and the clusters view roughly correspond to the application management and the application rollout parts. I want to start with the rollout a little bit and just go through some of the basics. Right? I said, let me just run a pipeline. I can choose the input that I want. What I'm doing here, I'm running the stage and verify. I'm picking a previous container tag that was run for this. I don't want to bother with the notifications. So I'm just short-circuiting the building of a new container in the interest of time. this thing triggers off a container build, not off a code commit. So this is what I was saying a little earlier about release candidates really being a common starting point for this thing. And now I have 2 pipelines running, and I can see the details. And this was triggered with this trigger a few moments ago, and there's bits running in parallel. So this is kind of interesting setup. This is a slightly microservice-y setup. And one of the problems in a microservice type environment is that if you've got, this only has 2 components, like a web and a worker. But we're not doing this bundling where once a day we pick the latest web and worker and deploy them together. We're actually trying to do each independently of the other, which, if they have stable API versions, should be possible. But what that means is that if I pick a new version of the web one, and I'm going to the staging environment, well, which worker version do I pick? Well, do I pick head? Well, that doesn't make any sense, because it's not going to be deployed with head, because head is probably not running in production. So I have to pick the current version that's in production. But how do I know which current version is in production? And if you've got a tool like a general purpose orchestrator, it really won't tell you. So you end up writing these really nasty, complicated queries against your runtime API to figure this stuff out. And in Spinnaker, it's just a single built-in command, get current prod worker version. So I'm just querying Spinnaker's notion of what's running in production, and I'm using that as a variable for the next step. And so I can do this the other way around as well. And so you can see there's some parallelization. There's lots of joining going on. I think this one is almost finished. I don't know. This one is still running. Yeah, this is scaling down the old version because I've run my tests. Well, wonderful, that's done. And then eventually it's going to, I think it's going to eventually start promoting to production, yada, yada. All not that interesting right now. That's some of the sort of basics of this particular setup. So let's look at a few more details here. Make sure I capture all these things. So there's a design, pretty nice design view. You can obviously make tasks dependent on lots of other tasks. There's some nice advanced things you can do here in terms of pipelines can be used. They can be locked so that people can use them but not edit them. They can be created as templates so that they can be managed from a code repository in the back end, but you can also do that in a way so that people can edit them. There's revision history checking, of course, so you can look at the diff between the last 2 revisions. I don't know what happened here. Let's have a look. Yeah, Vic made some change before me. This is actually JSON, so you can do the classic pipeline as code stuff where you have these in a repository and then you update them in your Spinnaker instance. And this time, skip. I'm not going to take a break. No time for a break. And then you can see, for instance, I don't know, you have lots of different options to trigger these things, from cron to code to CI tools to pub subs, webhooks, in this case, registries. And of course, you can have multiple triggers as well, parameterization, all the kind of basics that you would imagine here. Here we go, HTML in my notification. Yes, I'm about to approve the rollout to production. I'm going to do that. And now it's going to run in this production pipeline. And it's going to do some kind of interesting things with a sort of hot and warm and cold rollout scenarios. So we do some canarying, some sort of very vanilla canarying. We have an evaluation. And then if we abort, then we immediately roll back to the previous version, and we clean up the new version and redirect the traffic to the old version. Otherwise, we have this hot standby period where we decouple the new version, the old version from the load balancer, so there's no traffic going to it. Or if this is actually Kubernetes, so it's decoupling it from the ingress. But the processes are still running. So if I have to recover, it's a really, really quick action versus a sort of hot or cold standby where I still have the process definitions, but I still have to boot them. And so you get these kind of interesting, nice abilities to do things that, of course, you can also script by hand, but pretty clunky, not that easy. Right, look at the time. Oh, 6 more minutes. I've got to speed up here. So we looked at a few of those things. Let's have a look at the clusters view. So the clusters view shows us, that's the application management side. So we can see what's actually running where. So we can see I have V10 right now that's in production. It's still some work going on here. So there's a pipeline that's editing it. I can see some of the load balancer details that it's attached to. So I can click through to all this stuff, see some metadata. I can go down to each individual process. So I can see where this came from and what the events are that attach to it. I can look at its console outputs. I can even carry out actions on it safely. So I can take it out of the load balancer. I can do all these kind of things. And for instance, I could decide to disable this, but it's going to give me a warning. Like, this is the whole part of the safe management thing. Like, I have to explain why I'm doing this, and I have to confirm This is really what I want to do. Like, there's not going to be any active instances serving traffic after I've done this. Are you really sure? Are you really, really, really sure? Well, it's a good idea that you're asking me to do this. And so these are some of the kind of domain-specific smarts that I'm talking about when I say, this is what you should look for in a deployment tool if these are some of the challenges that you have. Right. Oh, 5 more minutes. OK. Let me just go back to see what else I was trying to talk about. So we covered a bunch of that stuff. Application management, yeah, we looked at the overview. I didn't talk about filtering too much, not that interesting. A traffic guard. I'm not going to go and find the page in where that's configured. But a traffic guard is this interesting thing that it can actually, for an entire application, configure this setup where if you screw up a process, execution, for instance, and you would ever get to a point where you were trying to run a command that there were no traffic serving an application, it will not do it. So there's this extra safeguard built into all the API commands that enable you to enforce some kind of invariance for your applications. What's the joke about automation? Like, manual errors break one thing. If you automate that manual script, then you break everything, right? So building safeguards into hand-scripted automation is an incredibly difficult task, and typically you only do it after you've broken everything. And breaking everything is a really bad place to be. We looked at some of the metadata, some of the click-through stuff. I didn't speak about deployment strategies, but again, these are things like red-black or Highlander. They all have fancy names. All it means is that you have different strategies for moving traffic from old versions to new versions, and whether the old version stays around or whether in the staging environment you don't care, you just want to nuke the old versions because no big deal, you want to clean up the resources. You will get all that kind of stuff out of the box. We talked about release trains, so it's getting a little confusing if I just dive into this. One of the nice things is that if you take general purpose orchestrators that are focused on code, like Jenkins, for example, or any CI tool, they typically assume that the first thing you want to do is clone one repository. So they give you kind of for free one set of source code. But when you're doing a release train, that's not what you want. When you're doing a release train, you want 7 artifacts for the 7 microservices that you want to deploy. And you don't want to get them from your source code anyway, because that's not where they're stored. So you want to set up a pipeline, really, or a bit of automation that says, well, the first thing I want as input is I want to get these 7 latest versions from these particular sources. And Spinnaker gives that to you as a first-class artifact. So it's not like you add 7 script commands, nobody knows what's going on. Spinnaker knows that it's operating on 7 artifacts, and it will surface the timestamps and the SHA signatures and whatever of each of those if you look at the pipeline overview. I talked about that earlier. I haven't had a lot of time to talk about the domain specifics, the domain abstraction. But one of the things that Waze, for instance, is really big on is that they run their same main application. So if you use Waze, the app, like part of that is being served by Amazon, and part of it's being served by Google for cross-cloud resiliency and all that stuff. And they don't want to have to look at 2 cloud UIs looking totally different to figure out what on earth's going on. So here you can just see there's basically no difference. You see one just from the account label that these are running in totally different cloud providers, but it really looks pretty much the same. I talked about time windows. Yeah, that's just one of those classic features of a deployment tool. Spend the last maybe 40 seconds to talk about canary analysis. Just because it's a recently released feature of Spinnaker, something called Kayenta. It's actually technically a separate service, but never mind. It integrates very tightly with Spinnaker. Doing canaries right is really hard. Like the way most people do canaries is going to spin up a new version, give it 5% of traffic. After n minutes for some arbitrary n that I feel like, I'm going to look at New Relic, and if it doesn't look too bad, I'm going to go, that looked good. That's kind of like homebrew canary. That's fine. And again, for 80% of your use cases, that may be good enough. It really doesn't work very well when you're doing applications at scale, because humans are really bad at making this judgment call. Why n minutes? Why not n plus 5? Why are you comparing a new version of an app against the production version, which has been running much longer and is taking much more traffic? That's a total not apples-to-apples comparison. The right way to do canary, in fact, is to spin up 2 new versions, your production version and the new version, and give them the same amount of traffic, and make sure they've run the same amount of time, and then to do a proper statistical test that detects anomalies. But who wants to script that? Nobody, because it's super hard. But it's packaged up as a service. So you get this kind of stuff for free, which is very nice. And it looks like this in Spinnaker. So you get, that you can look at the underlying metrics and go crazy about the graphs, or you can just say 85% is good enough for me, good to go. All right, 29 seconds. Right, some links. Don't copy these now, get them from the slides. Places to start out and have fun. Again, the 3 takeaways. Beyond a certain level of deployment complexity, and there were some questions about how to get those in here, it makes sense to look at the dedicated tool. A really good deployment automation tool supports best practice, not just for the process, but also for the application management side. Spinnaker is a tool that tries to embody a bunch of this stuff. 2 seconds ago, thank you very much.